All right. Let's start from the current slide, if it'll work. All right. That's Jermichael, right? Okay. Good deal. Anyone else come in since the call roll? All right, finally that came up. I've got to get out of presenter view, and the buttons seem like they have trouble waking up in the morning. Later in the day they do fine, but boy, early in the morning, they're like students. I mean, no, I didn't say that. Okay. Well, I think we're on the right. Yes, okay, we're here. All right. First, I want to know, any questions for anything we covered so far? None? Okay. Now, we already did example 6, but I only have it up here because there's not a place to write example 7. They skipped it. And we did 7A, but we didn't do 7B. All right, so recalling back, let me get my pointer. All right. Okay, everything's slow. I draw the line, and a few seconds later it shows up. Okay. Remembering what we're doing in example 7, the distance s in feet, okay, of a moving car from its stoplight is given by the function s of t. T is given in seconds, is equal to 20 times t to the 3/2 power. Okay? Now, the A part of the problem we did last time. What's the average speed of the car from T1 of 0 to T2 of 4 seconds? And the second part is T1 of 4 seconds. So from we're average speed, this what let's see. In one of my classes yesterday, these little icons wouldn't show up. It was frustrating. Okay. So let's get it back. They're slow even here, but they're slower the other way. I have to do it. All right. We're looking for the average speed of the car. Okay. Now, average speed, average rate of change. What's the formula for that? F of T2. Okay, except now, I forgot this. On this problem, we don't have F, we have S. So let's just go on and get that written as S's here rather than F's. Yeah, the formula says F, but it could be any name. We're going to use that. S of T2 minus S of T1 over T2 minus T1. Perfect. Now what they give us here for this B part of the problem is T1 is equal to 4 seconds and T2, this is okay, I thought so. Somebody else here and you not here. Okay. Okay. And T2 is, and will be 9 seconds. Okay? 9 seconds. Okay? So how do we find the average speed? First thing we're going to have to do is figure out what S of 9, okay? S of 9 would then be what? 29 to the 3 has power. Now you have to remind me, what do we mean to the 3 has power? Okay, you can either do it one of two ways. You can cube the 9 and then take the square root of that, or take the square root of 9 and then cube that answer. That's the easier way to go. The lazy way. Okay, you can do it the other way, but this is how I would recommend. And what is that? Say again? 27. Boy, do it all at one bite, okay? Because the square root of 9 is 3. 3's cubed is 27. So this is 20 times 27, and that is 540 feet. Okay? What else do we need to know? S of 4, and we actually did it last time, but it won't hurt us to redo it. Will it? Okay. What would that be? 20 times 4 to the 3 has power. And what is, which way you want to go on this one? 8. So it'd be 20 times 8. Because the square root of 4 is 2, and 2 cubed is 8, and that is 160 feet. If you remember, we had that last time. So now we just plug and chug. And what is our average rate of, or average speed then? You've done the hard work. What is this part? Second? Plug in, yeah. S of T2, T2 was 9. So S of 9 was 540 feet minus, help me, 160 feet divided by, okay, 9 seconds minus 4 seconds, okay? And that would be, what's 540 minus 160? A little louder? What'd you say? Okay, I can't hear. 76. Oh, okay, right, yeah, you've already done the answer. Okay, right, okay. 380, okay. 380 feet over 5 seconds, which is 76 units feet per second. See, the units are your friend. Yeah. What? All right. Now, the thing is, he was leaving from the stop sign, speeding up, so you expected that to be positive. If this were the other way, approaching the stop sign and slowing down, then sure enough, that would be a negative rate of change. You can't have a negative speed, negative rate of change. So we get 76, and they got 76 feet per second as well. Average speed during that time period. Now, let me remind you, I've said it before, but let me say it again. There are checkpoints after every one of these exercises or examples. Good things to go home and do as soon, or not even home. Go somewhere as soon as you can after class and at least get those done and then proceed with the homework, because these have the audio video solutions in English or Spanish at larsonprecalculus.com. And then the homework exercises have their solutions, odd number solutions. All the checkpoints are there. The odd numbers exercises are at calcheck.com. Okay, this book has great support. All right, any questions on that? Average rate of change looks a whole lot like a difference quotient. Exactly, okay? I know that was what you're saying. Okay, right. All right. Now, let's see if we can move. For some reason, the slide's not. Oh, okay, it's doing the stuff in the background. Okay. All right, even and odd functions. Boy, got a lot of odd functions in here. No. What does anyone know what we mean by even and odd functions? If not, we're going to get there. So let's do it. You have studied different types of symmetry of a graph. You have? Okay. Probably somewhere down the line. In the terminology of functions, a function is said to be even when its graph is symmetric with respect to the y-axis. It's said to be odd when its graph is symmetric about the origin. Okay? Now, I don't know if y'all are comfortable with what we mean by symmetric there. Here are the tests, and these are pretty simple tests, and they will be able to guide you in where you need to go here. Okay? But let me stop here, time out, and say, are all functions either even or odd? No. In fact, most functions are the third classification, which is neither even nor odd. So they left out the biggest class, the neither functions, okay? But the test will still show you. The symmetry test you use for even and odd, and if nothing works, they're a neither, okay? So here's what we do, the test for even and odd functions. Start with the function f of y is equal to f of x. That's what y always is, right? Now, it is even when for every x in that domain, okay, of L, if you put in a negative x rather than x, and then do the function with that, if you get the same answer with a negative x that you got with an x, that's an even function. Because you put a negative in, you get the same value as if you put a positive. That makes it symmetric about the y-axis, right? And Jajarian slipped in while I wasn't looking, didn't you? Trying to sneak by me, but I caught you, okay? There you are. Okay. Anyone else try the same? Okay. Okay. So that's what makes it an even function. Now, how do we determine if it's odd function? Well, when for every x in the domain, if you put a minus x in for x, guess what? Same thing. So if you do that, put a minus x in for x, if it comes out exactly the same, it's an even function. If it comes out exactly the opposite, it's an odd function. That means you put in a negative x, and it goes this way. Positive x, it goes that way. About the origin, that's an odd function. Put in a negative x, and it goes like this. Put in the positive x, and it goes like this, same value, and they're the same values, but just always opposite of each other, symmetric about the origin. But if you put in that negative x and calculate it, and you neither get the same thing or the opposite thing, it's a neither function. Okay? So that's the key. That's the test. Just plug in a negative x, see what you get. You get the same thing, it's even. Opposite is odd. If you don't get either of those, it's a neither. All right. Now, unfortunately, they told you the answer already. Okay? What are we going to do to that problem? Right there. Plug in a negative x. And when you put a negative x in, this gives you negative x in parentheses cubed minus a negative x. Okay? Now, what does that produce? What's negative x cubed? Negative x cubed. Okay? I hate that they're showing you the answer, but this would be negative x cubed. Okay? And what happens if you do minus a minus plus x? Now, how does this compare to that? Exactly the opposite. Pull out a minus sign and you get x cubed minus x. Yes, it's exactly the opposite. So what is that? Odd. I thought it was sort of odd, didn't you? Okay. So that's how you determine. Plug in a negative x. Okay, if it turns out opposite, you got an odd function. They got the same thing we did. Okay, which is pull out a negative x, you get exactly the opposite of what you had for g of x. Therefore, odd function. Okay? Now, what would you do here? Plug in a negative x. So you put a negative x in here, that'll be a negative x squared plus 1, no x there. What is negative x squared? Positive x squared, right? Plus 1. What's positive x squared plus 1? The same thing that h of x was. So therefore, h of negative x is the same as h of x. Therefore, it's even. Exactly. Okay? So let's see. Oh, let me get Jared, right? All right. Okay. And let's see how they proceed. They got that to be x squared plus 1. Good for them. Because square of negative, negative times negative is positive. Got it. Okay? That's exactly h of x. Because h of minus x is equal to h of x, that is indeed an even function. Okay. They didn't show you the third kind. We'll see one ultimately. Okay. Now, here's a graph of the first one. The x cubed, g of x, x cubed minus x. And see, that's, they drew the main diagonal here showing that every value here shows up there. Every time it crosses here, it's going to cross it there. Alpha minus x is the opposite of alpha of x. When this is going up, that's going down. When this is going, not just going, exactly the same values, except negative. Okay? And this is an even function. This is x squared plus 1, h of x. And notice there, reflective across the y-axis. Whatever you do on one side, you get the same answer on the other side. Okay, so that's your symmetric about the y-axis. That's an even function. Okay, y'all ready for me to tell you how to cheat a little bit? Now, this only works for polynomial functions. You know what we mean by polynomial functions, right? Okay. Let's go back and look at this. Polynomial functions. All polynomial functions have exponents, right? Look at your exponent. What's the exponent here? What's the exponent here? What are both of those numbers? What are both of those numbers? Odd numbers. And guess what kind of function it is? Odd function. Okay? Now, what's the exponent here? What's the exponent here? 0. X to the 0 is 1. Right? And what are both 2 and 0? Even. So therefore, this is an even function.
Does that work every time?
For polynomial functions. Okay. Now, what if you had an x in here? X squared plus x plus 1. What kind would that be? Not even, because 1, x, if you had an x in here, its exponent would be 1. That's why? No, it's not odd, because these two are even. It's a what? A neither function, okay? Neither even nor odd, okay? So it's really unusual, in some senses, to have purely even and odd. But when you do, that gives you some pretty good things. Let me get, I was starting to mark you with my ionizing pen. That wouldn't work. Okay. Diamond, right? Okay. Okay, good deal. All right. Any questions about even, odd, or neither? And I know you think I'm crazy here, but oops. Guess what kind of function that is? Odd function, exactly. In fact, this is almost the same one we had. Well, it's awfully close. Okay? How about that? Say again? Okay? If it was odd, the value here would be exactly the opposite of the value here. They're not. This looks like maybe, they don't have a scale here. Let's say if this was 1 right here, this would be 0.9, and this would be a 1, 0.95. Not the opposite of each other. It's a what? A neither function, exactly. A neither function. Okay? Because it's not reflected either across the y-axis, obviously, nor is it reflected across the origin. Okay? That's a neither. Most of them, I hate to say this, but in many respects, a lot of functions turn out to be your neithers. Okay. All right, good deal. That was the last slide on the page in the section. There is a little summary here. I highly recommend you review that. Make sure you remember everything that we did there. Let's do the vocabulary, top of page 56. Few of you have books. Those who don't, listen up. Okay? Top of page 56. Okay? The blank, blank, blank is used to determine whether the graph of an equation is a function of y in terms of x. Vertical line test. Excellent. Okay? Number 2. The blank of a function f are the values of x for which f of x is equal to 0. The blank of a function f are the values of x for which f of x is equal to 0. F of x equals 0. The zeros of the function. All right. Okay. The zeros of the function are those values of f, of the function f, are the values of x for which the function is 0. Okay? The zeros of the function where the function 0. Okay. Number 3. A function f is blank on an interval when for any x1 and x2 in that interval, and x1 is always less than x2, that implies that f of x1 is greater than f of x2. The function is what? If f of x1 is always greater than f of x2. Always. Decreasing function. You may have said it. I'm hard of hearing. Decreasing function. Okay? Number 5. The blank, 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 4 blanks here, between any 2 points, x1 and f of x1 and x2 f of x2, is the slope of the line between the 2 points. Average rate of change. And this line is called the blank line. Secant line. Excellent. Number 6. A function f is blank when for every x in the domain of f of minus x is the same as negative f of x. Okay, neither of those. When f of minus x is minus f of x. Odd, that would be an odd function when they're opposite of each other. Odd. If they were the same, that's even. Okay. All right. Homework exercises. I've assigned some of these before, probably many times. 7 and 9, 11 and 13, or either one. You don't need to do them both if you don't want to. Any of the odds 15 to 23. Any of the odds 25 through 29. Any of the odds 31 to 37, 39 to 45, 47 to 53, 55 to 59, either 61 or 63. That's the average rate of change like we just were doing. And then odd number exercises 65, we'll do 65, then either 67 or 69. Or both if you choose. And then the new stuff we did today, any of the odds 71 to 75, any of the odds 77 to 81, and then a couple more application problems, any of the odds 83 through 91. 91 is sort of writing, so basically 89 probably. Okay. But do take a look at all this. Now, the exploration part, don't expect to have many true false on your test. I don't usually do those. But still look at 93 and make sure you understand that. There's a think about it 95 and some graphical reasoning 97. Those are all worth looking at, but those are probably a little more esoteric or something like that. Okay, whatever that means. Okay. So let's move on to 1-6. Okay. Let's get out of this one. Go to 1-6. And when you finish 1-6, I will give you a quiz. I doubt if we're going to finish it today. I wish I had the quiz made up, so I give you the weekend to work on it. In fact, if you want that, I can run down right after class and make copies of the quiz. I just didn't have time yesterday to make copies. I forgot we were this close to finishing. That'll give you an extra weekend, if you choose to use it. Okay. All right, sped up a little bit. Like I said, the electrons are sleepy early in the morning. Okay. Got it. All right. That's, how did we wind up there? That's the average rate of change. Okay, I don't know how it did that. We're going to have to start over. And now, this one I was bragging on it speeding up some. It's not. Okay. This is strange. Back in Chapter 1, PowerPoint Lectures 1.6. Alright, it says it's going to 1.6. I hope it is. Ah, here we go. That's where we need to be. And I've still got to get out of this, go to that. All right, finally, we're at the right place now. If it'll decide where it's going to be. And it's decided to be offset. And why, I don't know. Now I think I've also lost my icons. So this is what it did yesterday. Makes no sense. Anyway, continuing functions in the graphs. If you haven't noticed it, this author loves graphing, okay? And we're looking now at a library of parent functions. We'll describe what we're talking about. We will identify and graph linear functions. I think we're pretty good at that. Squaring functions. I think we're okay at that, probably. We'll identify and graph cubic functions, or at least very simple ones. Square root functions, and reciprocal functions. We'll identify and graph step functions and other piecewise defined functions. We did a little bit of that last time in the previous section. We'll recognize graphs of the parent functions. The fundamental functions, the simplest of all these types that we're talking about. Those are what we call the parent functions. Now, sometimes they're so simple you lose what the rest of them are going to look like. We'll do it. But let's start with the easy ones, linear and squaring functions. What is it to make a linear function? What's a dead giveaway before you even graph it? Looking at it, what can you tell about it? What were you saying? What's that? Square root. No, a linear function is not a square root. Linear function what? Okay, of course it's going to be a straight line. That's where they get linear from. How can you look at that function without graphing it and seeing it's a straight line and know it's a linear function? Okay, you can write it in the slope-intercept form. That's one certain way. But notice about that. The maximum exponent of a linear function is, in fact, the only exponent you can have is 1. X is always to the first power a linear function. How about a squaring function? The maximum exponent is 2. So sure enough, look at your exponents. That's going to give you good hints. One of the basic goals of this text is to enable you to recognize the basic shapes of the graphs of different types of functions. For instance, you know that the graph of a linear function, as you just said, is a straight line. And you can write it, as you just said, as f of x, which is also y, is equal to ax plus b. Now, we're used to calling it mx plus b. Same deal. Okay. That's a line where the slope, m, is equal to a, and b is the y-intercept. Actually, the y-intercept is 0b. It's where x is 0, y is equal to b. That gives you the y-intercept. Okay? We're used to that. Y'all have done it probably for years, okay? Now, let's look at some of the characteristics of a linear function. Okay? The graph of a linear function has these characteristics. Guess what the domain of that graph is? All real numbers, because those lines go forever. Now, there's one line that doesn't have the domain all real numbers. And what line is that? A vertical line. Well, then, is this true? The domain of the function is all real numbers? If vertical lines don't have a domain of all real numbers, can those two jive? How? A vertical line, guess what? Fails the vertical line test, so therefore it can't be a function. So yes, this is true. If it's a linear function, it can't be vertical, because vertical line fails. Okay, so it's got to have at least some little tilt to it, and then the domain is all real numbers. Okay, when m is not equal to 0, now what happens if m is equal to 0? M stands for the slope, and a 0 slope would be what? Oh, they're all straight lines. Not vertical. Horizontal. All right. Like pulling teeth up here. I feel like a dentist. Okay. So, horizontal line when m is equal to 0. So if you have m not equal to 0, not horizontal, and of course it's not vertical because that wouldn't be a function anyway, then if it's not equal to 0, what's the range of that function? All real numbers, because they go on forever. Okay, and so it'll be all real numbers. If the slope is 0, what's the range of the function? Y is equal to b. That's y-intercept, because it's the same thing all the way across. So if m is equal to 0, the range is just the value y is equal to b. But if it's not 0, then it'll be all real numbers. Okay, the graph has an x-intercept. We usually don't care, but it is minus b over m. And the y-intercept, we know that is 0b. Now, how did they get that minus b over m? X-intercept. Say again? Y is equal to what? Okay, yeah, that's your linear function. Let me get my pen back. I have to use this now because it's offset. Okay, and that's exactly where we start. Y is equal to mx plus b. That is the equation, or f of x. That's the equation for your straight line, linear function. F of x equal mx plus b. Now, what is true about every x-intercept? Every x-intercept. What do we mean by an x-intercept? Say it? It crosses the x-axis. Well, what can you tell me about every value on the x-axis? If you gave me the ordered pair, what would be similar? Yeah, say it. What would? It would have a 0 in it. Where would that 0 be? y value, isn't it? The x can be anything. The y is always 0. It's neither up nor down. It's always 0. So the x-intercept is where y is equal to 0. So we're going to do that. We're going to set y is equal to 0 here is equal to mx plus b. Now remember we said m not equal to 0, right? That's the horizontal line. It doesn't have an x-intercept unless it's y is equal to 0, and then everyone's an x-intercept. So we're excluding horizontal lines here, okay? So how do we solve this for x? Find out what x is. Say again? Subtract b from both sides, and that gives us mx is equal to minus b. I'll switch sides too, okay? Then divide by m, and guess what you get? X is equal to minus b over m. There it is. That's the x value of your x-intercept. Okay, the y value is always 0. The y value is where y-intercept is where x is equal to 0. You put x equals 0, what do you get? Y is equal to b. So there it is, 0, b. Okay. The graph is increasing. This is linear functions. Anytime m is, positive, and it's decreasing anytime m is negative, and it's constant when m is 0. Always the same, okay? So we have our increasing, decreasing, and constant characteristics, okay? All right. Let's do example 1. Write the linear function f for which f of 1 is equal to 3 and f of 4 is equal to 0. That's a 0 out there. Okay. What is that linear function going to look like? Okay, how do you get that? We want to write that linear function. You described it for me really well. Say again? Okay, or f of x is y is equal to mx plus b. So in order to write that linear function, we need values for the m and the b, right? Because those are our constants. X is your variable, y is your variable, okay? So how do we get? Which one you want to go for first? Second? I can't hear you. Okay, and what are you going to do with that? Three goes in for f of x or y, yeah. Okay, that is really a great way to do this. I was expecting a different answer, but this will be fine. Let's do exactly what he said there. When you put a 1 in for x, you get a 3 for f of x. So this will be 3 is equal to m times 1 plus b. Right? Is that what you were meaning? Now let's do it for the second set. What would that tell you? 0 is equal to? Say again? A little louder. What's your x? 4 m plus b. I wasn't expecting to do it this way, but it certainly works. Okay? Now, what do you do from here? This is a system of 2 equations, 2 unknowns. Anyone remember how you did something like this? Oh, that's way back.
The x and y intercept, one of them, the x and y intercept is just the set of 0 and something else, or something else and 0. Right?
Okay. So you know one of those. Which do you know?
0, and the other is going to be 4.
Okay. Which is that? You keep calling it the other. What's its real name? No. Okay. M is a slope. Okay. I thought that's how you were going to begin the problem, but you gave me this. This is a perfectly good way to do it. We'll come back and do it the slope way too. But what I thought I heard you were saying, this statement right here gives you the x-intercept. So that's not really useful in coming up with an equation, okay? But that does give you the x-intercept, you're right. This is useful. We can solve for one of those two variables. Which is the easiest one to do? In fact, here's how you do this. Which is the easiest one to eliminate? The b. How would you eliminate that? Subtract. Okay, which one you want to subtract? I don't care. We're going to negate one of those. Which one you want to negate? Top or bottom? Say again? Huh? Okay. You have to do the whole equation. Top? Okay. We're going to negate the top. So that gives you minus 3 is equal to minus m minus b, right? We just negated the top one, wrote it here. Now you can add the two equations together and you eliminate the b, right? It's called elimination by addition. Y'all remember this, right? Been a long time, okay? So add those two and what do you get? Negative 3 is equal to 3m. The b's go out, so guess what we got? Divide both sides by 3, and you get m is equal to negative 1. You're absolutely right. That's one way to get the m. I'll show you a different way in just a minute. Okay, yeah, okay. Graphing, you can see what's happening. It doesn't necessarily tell you the it kind of can tell you the equation. We're looking for the equation. Write the linear function, the function. So we got the m part. How are we going to get the b part? Plugging in the m, you choose. Top or, first or second. I don't care. First one? Okay. We'll use that one. And it says that 3 is equal to minus 1. That's your m plus b. Solve for b. How would you do that? Second? Yes. Add 1 to both sides, and that gives you. Second? B is equal to 4. I can't hear. Okay. All right. So now we have our equation. Write the linear function. That would be minus x plus 4. Okay? There is your linear function. Now, how I was expecting you to do it, this is a perfectly good way to do it. But what I was expecting y'all to give me was, when I said, how do I find one of those two? Which is the easiest to find first? I was expecting to hear the what? Okay. Usually it's not. In this case, it happens to be, but that's sort of strange. Actually, the easy thing to do is a slope. Because how would you define slope? Back when you first learned about slope, how did you define it? M is equal to what? Rise over run. What do we mean by that? What is your rise? Change of your y values, exactly. And which are your y values here? Wait a minute, what? I thought f of, this stands for f of x is equal to y. You are supposed to remember that, remember? Okay, so which is the y? The 3 and the 0. Okay, which one was you want to take the difference of? How do you want to do that? Say again? Which one you want to put first? I don't care. Say again? 3 minus 0. Okay, once you choose that, I do care. Because now you have to do your change of x's, that's your run, the same way. And what would that be? You can't swap. 1 minus 4. See, I said it. It mattered, didn't I? Okay. What would that be? 3 over negative 3, which is negative 1. Sure enough, there you have it. Okay? Got the same answer for m. Okay. Now, if we were doing that way, then what you could do, just like, well, kind of like we did before, once you have your m of -1, pick either one of those. Doesn't matter which one. You want to pick order pair 1, 3 or order pair 4, 0. I don't care. Pick one. Second? 4, 0. Okay? So we'll do -1 times x, and you said 4, plus b, that's what we don't know yet, is equal to 0. Okay? The y value. And this would be -4 plus b is equal to 0. And guess what? Solve for b, add 4 to both sides, and you get b is equal to 4. And you came up with the same thing. So f of x is equal to -x plus 4. Now, it just was lucky or coincidental that your x-intercept and y-intercept have the same values. Don't expect that to be the case always. It generally is not. The reason for this is this had a -1 slope. So with a -1 slope, if it goes through 4, 0, a -1 slope is also going to go through 0, 4. That's the reason they turned out the same. Don't expect that to be the case in general. But either way you want to do it, choosing to plug in your values and solving 2 equations to unknown, that works fine. I suggest elimination by addition. You could have chosen substitution. You could have said b is equal to -4m or b is equal to 3 minus m. You could have done that, then plugged in the other one. To me, it's a little more work, but I like elimination by addition. But there's several ways to do it. Or, as you said, if you're careful with the graphing and graph the 2 points and then calculate your slopes, you can do it that way too. Okay? So, let me erase all the ink. And since it won't let me get to that, we'll do it here. And let's then proceed from here. To find the equation of a line that passes through these 2 points, and you see they identified those as ordered pairs. X, Y, X, Y. Remember? Okay? Ordered pair 1, 3 and 4, 0. Okay? It said first find the slope, rise over run, change of y over change of x. Oh, they used a different y, didn't they? They used 0 minus 3. Oh, that's not going to work, is it? Yes, it will. It doesn't matter which one you use first, okay? But once you use it, keep them in the right order. So if you do 0 minus 3 divided by 4 minus 1, you get a -3 over 1, which again is -3. And let's see if that's how they did it. Yep, 0 minus 3 divided by 4 minus 1, -3 over 3. It's a -1 slope. We've done it 3 different ways. I always came out with that. Must be right. Okay? Now, next, this is a different way to do it. Perfectly fine, though. Use the point-slope form of equation of a line. Y'all remember that one, don't you? Oh, you do. Good for you. Okay? Y minus y1 is equal to m times x minus x1. Okay? Perfectly fine to use this. You pick either one of the points, and it doesn't matter which. What were they again?
0 and 3.
Say again?
0 and 3.
Okay. I don't think so.
It was 4 and 3. 4 and 0. 3 and 1.
I think so. Have you got the right order? I'm trying to remember. I don't remember the problem. Let me look. 1 and 3 and 4 and 0. Okay? And you can do either one. If y is 0, then use 4 here. If y is 3, use 1 there. Whichever. Doesn't matter which one. Just use the right, but keep with it. So y is equal to 3, x equal 1. Plug that in, and plug in the -1 here. Okay? And this will give you y minus 3 is equal to -x plus 1. Add 3 to both sides, you get y is equal to -x plus 4. And sure enough, that's your equation of the line, -x plus 4. It's not the equation of the function. You put the f of x in for y, because f of x is equal to y. See? You remember that? You got half of it not equal -x plus 4. So you see 3 different ways to do this. Okay? You pick the one you see and you understand and you're most comfortable with. Do it. As long as every step is right, you should come out with the right answer. Take any missteps, you're probably going to miss the problem. Okay. Make sense? Any questions? You do what makes the most sense to you. None of these is any better or worse than the others. Some of them may be a little longer, but if you see it, go for it. And here's that equation. I sort of arm waved it over there. Here's the graph of it, which is what you want to do to begin with. Here were your 2 points, 1, 3, and 0, 4. Well, no, 4, 0. Okay? Those are your 2 points. Draw the line through there. You can see your y-intercept if you do right, and then you look at that and say that's the slope of it. You drop 1 for every 1, you go to the right. So that's a -1 slope. So you could kind of do it that way if you're very careful and precise in your graphing. To me, that's a harder way because it introduces more possibilities for error. This is showing you the graph, and sure enough, everything fit. Any questions on that? All right. So there are 2 special types of linear functions. Okay? That was a linear function. But there's 2 very special types. The first of these is the constant function. We've already sort of talked about it. What's true about a constant function?
The x doesn't change.
The what?
The x
What about it?
value doesn't change. It's always 0.
Okay, the slope is always 0. The coefficient for x is always 0. That's what makes it a constant function. It's a horizontal line. It never varies. The y value doesn't change. It's constant. So that means the slope is 0. And if the slope's 0, I wish I hadn't put c. What would I put? B. That's your y-intercept, isn't it? Okay? But they put c. Why? Because it's a constant. Okay? So it doesn't matter what you call it. That is your y-intercept, and that's the only value x ever has. I mean, y ever has. Y is equal to c. So what's the range of that function? The domain is all real numbers. The range is? It never changes. The y value is always c. Okay? That's the range. It never changes. It only has one. Has a domain of all real numbers, but the range is that single number c. Because it's a constant function, it never changes from there. You can't get c plus 1 or c minus 1. You can't get anything other than c. Okay. The graph of a constant function is what has been called a straight line, but it's really a horizontal line. They're all straight lines. Shown in this figure here. This looks like that c is something like maybe what, 1.3 or something like that. We don't need to know. It's always that value. It never changes. So its domain is all real numbers, but the range is that value right there, and that's it. Y is equal to c. Okay? So, this should have been on the next slide. Okay? Starting right here. The second type of these special functions here of linear functions is the identity function. Okay? Anyone want to make a guess of what that is? Okay? Not absolute value, that's a different function. The identity function is similar on one end to that, and that is the function that what is f of x? Y is always x. In other words, give me an x, give me an x. 0, guess what the y is? 0. Give me another x. 3, guess what the y is? 3. Okay, they're always the same. That's why they call it the identity function. So what does this graph look like? Say again? It's a straight line. You're absolutely right. What's the slope? F of x equals x. 1. What's its y-intercept? What's the y-intercept? Do you see one? Guess what it is? 0. It crosses the y-axis at 0. Okay? So the slope is 1, the y-intercept is 0. Okay? What's its domain? All real numbers. What's its range? All real numbers, because whatever x is, y is. If x to be all real numbers, y has got to be all real numbers. Okay? X-intercept? Does it have one? 0, 0. Y-intercept? 0, 0. Okay, let's go back to your constant function. X-intercept? It's not an x-intercept unless, of course, c is 0, and then every number is an x-intercept, okay? They sort of leave that one out. They don't even count that, you know. So it does have an x-intercept. What's its y-intercept? C, okay? It's got to be, okay? Good deal. Okay. Is this an increasing or decreasing function, or neither, or both, or constant? It's what? It's always increasing. Why? Slope is positive. Exactly. All right. I think we beat that one to death, didn't we? All right. Now let's look at the squaring function. Now this is a very special, basically called the parent function of all your quadratic functions. Squaring function, obviously the exponent is 2, okay? In a quadratic function, you can have x terms and constant terms. With a squaring function, that's all you got. F of x is x squared. Now, I don't really like that they call this a U-shaped curve. There's a reason they do that, but it's not really U-shaped because a U goes up straight here. The U-shape means the bottom is curved, okay? Now, the absolute value function, that's a V shape at the bottom. The U-shape is curved at the bottom, and the squaring function has that curve in it. It just doesn't go up straight, it keeps going out. What do you reckon the domain of the squaring function is then? Actually, it would help to see a picture of it. Let's do a picture first. There's the squaring function. When x is 0, y is 0. X is 1, y is 1. When x is negative 1, y is 1. When x is 2, y is? Okay, what? The domain? You're absolutely right. All real numbers. What's its range? Only 0? 0 to positive infinity, exactly. Okay? All non-negative zeros. Non-negative numbers, okay? You can't count any negative numbers in there. 0 you can't count, all positive numbers, exactly. Okay? So let's go back. There's the range. Domain is all real numbers. Range is all non-negative real numbers. In other words, like you said, from 0 to positive infinity, counting to 0. That's a bracket there. You see it? Okay. All right. How about the even and oddness? Oh, wait, we forgot that, didn't we? Let's go back to this one. Is this function, constant function, even or odd? Or neither? That's what? This one's even. It reflects across the y-axis. Whatever you have over here, same here, because it's always the same. So the constant function, and I'll say this, is the only linear function that's even. The only one. Okay? How about your identity function? Odd, because it reflects about the origin. Okay? And it's the only linear function that's odd. Every other linear function is a neither. Okay, you're absolutely right. Okay. The squaring function, on the other hand, is always what? Even, odd, or neither. Even, okay? Whatever it's doing on the right, it's doing on the left, okay? It's an even function. Good. Okay? What's this y-intercept? What's its x-intercept? 0, 0, okay? It crosses both, or touches both axes at 0, 0, okay? Now, and that's the only function. Okay, let me see. No, I skipped too much. No. Has an intercept, they don't say which, both x and y intercept is 0, 0. How about increasing, decreasing? What about it? It's what? You have to give me ranges here. With linear functions, they're all one or the other. Any curve function, you're going to have something else going on. So what can you tell me? It's from negative infinity to 0, increasing from 0 to positive infinity and beyond. Okay, so it's decreasing from negative infinity to 0, increasing from 0 to positive infinity. And notice here, they really don't count the 0 on either one of those because that's where it's changing. So when you talk about intervals for increasing, decreasing, just put them all in parentheses. Okay? What is it? Does it have any symmetry about it? How? What? Symmetric about the y-axis, exactly. Okay? The graph has now we haven't mentioned that before. Does it have a relative minimum or maximum? Say again? Yes, it has a relative minimum where? At 0, 0. We also call that the vertex. Okay, does the identity function have a relative minimum or maximum? No, it doesn't. How about the constant function? It's constant. It's both minimum and maximum. It's always the same. Okay, so that's sort of a dumb question for that. Okay. I think we beat that one to death too, didn't we? All right. Any questions on those two types of functions? Now, there's very few examples here, okay? All right, so let's go to cubic, square root, and reciprocal functions, okay? Number one, tell me, what do we mean by cubic function? Second? Okay. Square root would be a square root function. What do we mean by cubic function? The what? The variable, the maximum exponent is 3. How about a square root function? Okay, it's a square root. What about its exponent? Exponents are important here, if you've not noticed. Okay. Say again? No, that's a quadratic or squaring function. What's the exponent for a square root function? Sort of a tricky question. 1/2. You're absolutely right. Remember we had that before. Okay, 1/2. The exponent is 1/2. How about reciprocal function? What's the exponent? What do we mean by reciprocal function?
Negative.
It's a what?
Negative.
Negative what?
Exponent.
1. Okay, very good. Okay, it's a negative 1. Okay. And you can have other reciprocals. You can have reciprocals of squares and stuff. But the reciprocal function is 1 over x, which is x to the minus 1. Very good. Y'all already got half of it done. Okay. Following summarizes the basic characteristics of these. Cubic, first, square root next, and reciprocal last. Let's start with the cubic. What you reckon the graph of the cubic function, alpha of x. Now this is the parent function, the basic, simplest cubic function, alpha of x equal x cubed. Now once you start adding more terms on, square terms and linear terms and constant terms, you get other things happening. But for the simplest, the parent function x cubed, let's think. What is its domain? All real numbers. Okay? All these polynomial functions, always all real numbers. Hint, hint. Okay, now, how about the range? Cubic function. Give me an x. 1. What do you get x cubed then? 1. 1 1's there. Give me another x. 2. What would you get? 8. Very good. Give me some negatives. Negative 2. What would you get? Negative 8. So guess what it looks like the range is going to be? All real numbers, because you have positive and negative. For the squaring functions, whatever you do to it, you're going to get a positive number. This one you get positive and negative, so it's going to be all real numbers. Okay? Domain is a set of all real numbers. Range is a set of all real numbers. Okay? How about even and odd? Odd, because you just said 2 is 8, negative 2 is negative 8. 1 was 1, negative 1 is negative 1. Okay, 0, 0. Okay, so yeah, that's an odd function. All right, how about intercepts? Does it have an intercept? 0, 0 is x and y intercept. You're absolutely right. Okay? Is it increasing or decreasing or neither? Or a constant or what? Increasing everywhere. Okay, we talked about this before. It might look to your eye, and this is why graphs are a little tough to determine things. It might look like it almost gets constant right at 0, but it doesn't. You pick a number very close to 0, like 0.001. Cube that, and you get 0.0000001, but it's still constant. It's not ever constant. Okay, pick a negative number like, let's do a simple one, negative 0.1, then you have negative 0.001, still negative. So it is increasing everywhere, even at 0. Okay? Increasing over the entire interval minus infinity to infinity. Okay? Now, does it have any symmetry? About the, oh no? Is that what I heard? Yep. Okay. What's the symmetry? About the origin, because whatever is happening on this side is happening the same on the other side. If it's odd, it's symmetric about the origin. If it's even, it's symmetric about the y-axis. Okay? And we already said it was odd. Okay. Strange anyway. All right, there's the graph of it. All right. Does it have a relative minimum? No. Relative maximum? No. It's always increasing. It can't have either. All right. Good deal. Now the square root function. This is what it is. Alpha of x is equal to x, the square root of x, which you could write as x to the 1/2 power, exactly. Okay? Usually, calculation-wise, that is what we're more used to. But in terms of visualizing the function in some senses, especially, I hope some of you will go on to take calculus. This is pre-calculus algebra. If you do, you'll see a lot of times, if you take me, I'll say, I never want to write it in that form, in radical form. I want to write it in exponential form. Just so much easier to work with. All right, so what's the domain of this function? Second? You cannot have negatives. Very good. I thought y'all were going to say all real numbers. You can't have a negative number, so it goes from 0 to positive infinity. You cannot take the square root of a negative number. So how about its range? How about its range? Say again? 0 to positive infinity again, exactly. Because basically we call this the principal square root, principal meaning positive square root. You have to put a minus sign in there to make it negative. Okay, that's not the function we're dealing with. I see a little motion. Does that mean we're oh, how sad, just when we were having fun, but we're always having fun. Okay, do y'all want to hang around a little bit and me go run off the quiz for you? What's that? Oh, you do? Okay. Does anyone want a quiz today? Okay. Let me do a couple things here.